Hello, this video is going to address the concept of angles, introduction to what is an angle, what are the different parts of an angle, and what different types of angles are there. And this is for Math 7 for the week of April 13th. So I just want to start it off by helping you to understand the concept of angles. So let's look at first what are different angle concepts. All right, so first of all, when you hear somebody say he just did a 360 or she just did a 360, what exactly does it mean when somebody does a 360, right? And you might think, well, you're picturing something in your head kind of like this, where you're facing one direction and see that dog just ends up completely turned around, facing the same direction, well, almost facing the same direction as when he started, right? So that would be like a 360. That's a pretty talented dog right there. And what does it look like when somebody does a 180? And for those of you who are into BMX bikes or skateboarding or anything, know that a 180 would be you are facing one direction, just like this car right here, and then you're doing a little rotation and you're facing the exact opposite way of what you started, right? So that's what a 360 looks like. This would be what a 180 looks like. But what would it look like when somebody is doing a 90 or when somebody's doing a 45? Do you know what those would look like? Well, they would be rotating, but just maybe not as far as in both those cases, right? So when you're talking about these numbers, 360 and 180, you need to understand that they're all based on a measurement of degrees. And when somebody does a 360, you can see that they're going in one direction. Well, if they would be rotating this way, they're going all the way around in a rotation, facing the same way that they were facing when they started, right? So that is doing a 360. Doing a 180 would be facing this way, and then when they do the rotation, there is 180 degrees right there, and then they're facing the opposite way. So that is doing a 180. So if somebody was doing a 90, they're facing this direction, and then they're facing directly to the left, or maybe perhaps to the right. Okay, we'll talk about the direction and all these numbers in a bit. So if they're doing 45, that means they're only facing this far away from where they first started, right? So that's what those numbers pretty much mean. And this kind of should give you the idea that when you are talking about angles, angle measurements, that angles are measured using a protractor. So, but first we want to talk about the different parts of an angle. Angle is made up of three parts. Okay, so the first part, it has to have a vertex in order to be, it has to have a vertex in order to be an angle, and it has to be made up of either a ray or a line segment and another ray and a line segment. So it has to have all three of those parts in order to be an angle. Okay, so there's four different types of angles that we're going to be going over today. There's plenty more, but the ones that we're concerned with right now are these four. And one of the easiest ones to remember is right angle, because a right angle is just 90 degrees for one thing, and we know the way it looks. One of the rays is just perpendicular to the other ray. And when we're talking about acute and obtuse angles, you might be familiar with these from elementary school, is an acute angle is an angle that's less than 90 degrees. That means it can be this one right here, or it can be this one right here, just as long as it's less than the right angle. So any angle that's more closed would be an acute angle. And we know an obtuse angle is bigger than a right angle, so that means it would be this ray and anything on that side of the right angle. So it's more wide open than a right angle, so that would be obtuse also. And the fourth one would be a straight angle, and that is basically a straight line, but if it does not have a vertex, then it's just a straight line. Okay, but the fact that it has a vertex there means that this is one of the rays, and we're measuring all of this degree measurement right here to the other ray, and that would be 180 degrees. So this is kind of a review of some concepts that you got in elementary school. Okay, so angles are all measured with a protractor. Here's what a protractor looks like in case you've never seen one. And just a quick review. Let's say we have an angle. Here's an angle, this red one, and we want to measure how many degrees that angle is. So first, we identify the vertex. There's a vertex. Now, to measure with a protractor, the vertex must be right in the center of the protractor. In this case, it's right here. Okay, so that's the center. We know it's the center because it's where the zeros and the 180s line up with the 90. Okay, so it's right there. So the vertex is lined up at that center, and then we need to make sure that the ray that is on the horizontal, well, it's going to be horizontal depending on how you're holding the protractor, but one of the rays has to be lined up with 0 degrees. Now, this is also lined up with 180 degrees, and I'll explain that in a bit. Okay, so you have to have two things. The vertex is on the center, and one of the rays is lined up at 0 degrees. Now, if we want to measure this angle right here, then we need to consider a couple things. One is there are two different degree measurements here. There's 50 and there's 130. So which one is it? Well, first let's look at the angle as a whole. Is it an acute angle, or is it a obtuse angle, or is it right or straight? And the answer should be this is an acute angle. So if it's an acute angle, which one of these two angles would make sense, 130 or 50? Right? So the answer would be 50 degrees makes sense. Now, another way of thinking of it is when we lined up our bottom ray with 0, that means we're not starting with these numbers here. We're starting where 0 starts. So 10 degrees, 20, 30, 40, 50. So in this case, we're looking at the inside because that's where 0 is. Okay, so that's one way of measuring those. Now, what about the other side? Well, on the other side, let's look at this. Okay, first of all, we have our vertex lined up in the center. Okay, close enough. And this ray is lined up at 0, but as you notice, in this case, the 0 is on the outside and not the inside like it is here. So that means we're not counting the inside numbers. Okay, and secondly, looking at the angle as a whole, would 50 or 130 make more sense since this is an acute angle? And the answer would be, well, 50 makes more sense. So that's how you can tell. One, where does 0 start on the outside? Where does 0 start on the inside? And then measure from 0. Okay, so all those things have to happen when you're measuring angles with a protractor. Okay, so let's look at a couple, just kind of practice, see how you're doing here. So look at that angle and go ahead and pause it and see if you can guess what is the degree measurement of that angle. Just take a guess, take a wild guess. Okay, so if you paused it and you're ready for the answer, you should have gotten, we'll get to the answer in a bit. Okay, so look at this angle measurement. What is it? Go ahead and take a guess. Okay, look at that one. Take a guess. Look at this one and take a guess. All right, so here's a protractor just to use for reference. So if you're looking at the angle measurements here, oops, sorry. So if you're looking at the angle measurements here, this is approximately, you should have gotten about anywhere between 15 and 20 degrees, then you're correct. Okay, for the second one, this one is approximately 135 degrees. Okay, so this is about 135. Okay, this one was about 15 or 20 degrees. Okay, and then this angle here is about 45 degrees. And this angle here, that one of the easiest ones to identify. This is 180 degrees. This is a straight angle. All right, so hopefully you did well on that one. So here is the next exercise. Here is an angle being measured by a student with a protractor. And can you tell, first of all, what mistake did this kid make and what would the actual measurement be? Now, if you have a protractor handy, then you could probably hold it up near the screen to tell. So go ahead and pause it, work it out in your head. Okay, so if you answered the vertex is not lined up at the center, then you're correct. Okay, so this vertex should be right here. Okay, and it should be lined up at 0. So the actual measurement of this would be about 50 degrees. Okay, so if it was lined up correctly, here's what it would look like. All right, here's the second one. Okay, so what did this student do wrong? All right, if you guessed that the bottom ray is not lined up at 0 degrees, okay, if the bottom ray is at 30 degrees, it should be here at 0. And we're reading the inside, right? So this actual measurement should be 70 degrees. All right, so this angle should look like this. All right, next one. Okay, what did this student do wrong? All right, so your guess should have been the vertex is not lined up at the center. Okay, so the vertex should be here at the center. And also, it's not lined up at 0. This one is somewhere between 10 and 15. So this should have been lined up right here. Here's what the angle should have gone. And this one is approximately, I mean, it's close to where it's supposed to be, but this one is about 77 or 78 degrees. So it would be off if you don't put it in the right place. All right. And then the next one. All right. So what is wrong with this child's work? All right. And the thing that's wrong with this is not the fact that the vertex is not in the right place. The vertex is in the right place. The ray is at 0 degrees. But the only thing is, what kind of an angle is this? Is this obtuse or acute? This is an obtuse angle. So 120 degrees. It is not 60 degrees. Okay, so that's your introduction to angles. We will take any questions that you guys might have, and we'll let you know what the work is, the practice problems that follow this assignment.